Hello guys, let's start driver sheet. Let's start it from the back. So we get the hardest questions first or randomly, and then let's do it. Let's do it. Given a string S, you have to find the number of palindromic subsequences, not even necessarily to be distinct present in the string. Okay, cool. So how do we do this? Palindromic subsequences. So what is a palindrome? Let's say it is equal from reverse and from the forward. And what is a subsequence? So A, C, D could be a subsequence, A, B would be a subsequence. So any combination of this letter in order is a subsequence. Okay. So let's see what could be the palindromic subsequences. Okay, so let's say I start from A and D. Is it a DP problem? Is this a DP thing? Uh, I try to find a palindromic subsequence of 4. I don't. Palindromic subsequence. How do I find a palindromic subsequence? A, B, C, D. So obviously all of them would be palindrome in itself, but let's take an example A, B, C, A. If I find A and A, let's say front and back, I check and I find A and A, or should I start from the center? I should start. So if I'm at A, let's say, I can't go left, I can't go right. That's okay. I'm at B now. Now I can go A. I can check for A and C, but okay, those two are different. I can increase. I can check for A and D also. I can check for. So how do I do that? That would be a problem. For C also I can this, but it's- it is a subsequence. No, it is not a sub array. If it was a sub array, I think I could have easily done it. But subsequence. B B. I come to B. I try to find something that is equal to B. Okay, so this does not work. Let's say I store the letters. Okay, so I am at A and the S is A, B, C, A. Okay, let me check what will A, B, C, A give. To submit on GFG. It should give 5, I guess. 7? A, B. Okay, huh. So it will give 7 because A, B, A, C, A, that, that 3, and then, okay. So I'm at A. I know that there is another A. Okay, so subtract A. Okay. I know there is one another A on the right side. So I um, make it +1. Okay. +2. Okay. Now I'm at B. I know there is one A at the right side and one at the left. Do I make two arrays of right and left? I think that would help. That should help. Okay. I think that is something that is required. So I make, yes, we draw A, B, C, A. If I make an array of call right, starting at 2, comma, even 1, because we are starting from the first zeroth index. So for that, it will be 1, comma, or 2, 2, comma, 1, comma, 1. Okay. And left. And start from 0, comma, 0, comma, 0. Okay. And now I come at A. Okay. So I'll reduce this to 1, and I find there is one another A on this side. So I so as A is 2, I it is even. So I add A. A is greater than 1. As it is greater than 1, I add A. If there were 3A, what would have been? AA and AAA and A. If there were 4A, then A, AA, AAA, AAA. Okay, so I subtract one A. I see there is the number is 1. I add 1, and I add 1 for this. Okay. Now I come to B. I subtract this, and now for A, I before ending, I do this. Okay. For B, I check these array. The one is at the right, one is at the left. So I make that. Okay. Now that would still be a problem because let's say I have this, I have this d comma e. Because of this, like for B, will be on the left, one will be on the right. Now I can take this. I can also take this. These are two palindromic DBD and ABD. But if this D was replaced by A, if the input was different, then ADBDA would have also been a valid solution. So how do I know that? There's no way to know that. I don't think that solution will work. Subsequences. If it was substring, it would have been easier. But subsequences. A, A, B, C. Do I make all the subsequences? Size is 30, 2 is to 30. Uh, topics now. It's a dynamic programming topic. Okay. Yes. I think I'll have to make. How do I handle even and odd then? I'll spend 15 minutes trying to find the solution. If I don't, I'll try it. I'll look at the solution. That I think that rule is good now. Okay, A, B, C, D, A, B. I take A in the solution. I decide to not take A. Okay. And I check is spell now. Okay, I think I can do it using dynamic programming. Let's see. So let's make the string go global. S S this dot S so S S T. Okay. Now what I do is first thing if I is equals to n, I is equals to n. In that case, the 0. Cool. Now if not palindrome st return 0. Okay. If st is not palindrome, then also will return 0. Okay. Is palindrome better naming and mm, return st is equals to p down here. I think I can do this. Reverse string CTP. Is this possible, or I will have to? I don't want to do this. Ah, I will have to, I guess, do this. So, and is palindrome. Alan, Alan is palindrome. The compiler feels slow. My output is 10. Okay. The actual output should have been. Hmm. So how does my thing works? It comes to A, it finds. Okay, I guess. Hmm. So so it comes to A, it finds that it's not equals to N, I is not equals, and A is a palindrome, so it will return one without, first one without. It comes to B, B is a palindrome, and without. This without one is also counted at the end. So if is palindrome, then only I'll do this. Or else if it's not, that's the one. If it's not, then I'll move on. If it is palindrome, then I should include it. Is that the case? This should work. Mm. Okay. So it comes to A, it finds that it is a palindrome. So it goes to A, B, and it finds it is not a palindrome. So it, from that it comes to, in that it comes to this, and it goes to A and C, and that it finds it's not a palindrome, so it comes to this, and that it goes to A and A. It finds that it is a palindrome, so it comes to this, I is equals to N, and it returns, that will return 1, and at the end it will come back and it will return 2. Cool. When we come to B, into the same debugger. This should work. This should work. Why is this not working? Okay, I should also do this. Yeah, that makes sense. TLE, I think I should get a TLE. Exactly. How can I optimize this? No. So let's make a hash table of I and map. A little memoized. Sincerely. What is my time? Okay. How do I reduce it even more? At the 40-minute mark, I'll just look at the answer because now I've coded and like that's why the 15-minute mark is gone. Subsequences. A, D, C, D. How can I optimize this? So the problem is that I'm producing all the subsequences. Is there a way I don't do that? A, B, C, D, A, B. A, B, A, D. Let's say A, B, A, D. Well, A, I find another palindrome. If I think I should look at the editorial now. Mine is no better than brute force. I use Dunbar solve because I'm solution having overlapping. Okay, yeah, bro. I don't know what are they doing. They are just writing uh, the final approach from the beginning itself, which is not fair. It's a good question. Let me think a little more after seeing that, though I don't understand any of these. Just, if I can derive it, I'll be happy. I get an idea from this thing. So basically, it's saying that if I only had this string, the answer would have been A. If I only have these two string, the answer is 2. If I have these three string, so if I have only A, B, the the answer is, if I only have B, the answer is 1. If I only have B, C, the answer is 2. If I have B, C, A, the answer is 3. And if I have A, B, C, A, then answer 7. How do I write it in this form? Time, it's time. Palindrome.
The problem says that will be given a string which will be of length n, and our task will be to find the number of palindromic subsequences. Have to count the number of palindromic subsequences. From this string, I take this x character and something like this. If x was there, this one I choose this. In that case, you can see that this particular subsequence of the string is nothing but that's what we have to do in this particular problem. And since the answer can be very large, so we have to return it modulo 10 to the power 9 plus 7. Now, for doing this kind of problem, the first prerequisite is that you should be very well aware about the longest LIS, right? You should know the LCS, that is the longest common subsequence questions, the category of longest common subsequence, and also the longest palindromic subsequences. If you are well aware about those concepts, then this problem becomes a cakewalk or a very easy problem for you, right? So if you have not done those kind of problems in DP, then you should try them out as well.
I have the longest common subsequence. I have not the longest palindromic subsequence.
Now, if they give you a string, let's say as ABCD, right? So if ABCD are given, so in this particular string, you can see that all the four characters are different. So basically, if I consider the individual subsequences, that is just A, or just B, or just C, or just D. So in that case, all of the single characters alone are palindromic in nature, right? Because single character is palindrome. So I'll write the answer here as 4 for this particular case. Because if I consider ABC or anything else, then no other subsequence seems to be palindromic. So the answer for the first test case will be 4. Now, if I check out the second test case here, so the second test case is double A and then D, right? So if we have, let's say double A and then D, so in that case, what we will be having is we'll be having this single A, then we'll be having the second single A, then we'll be having D, and then we'll be having A and A as well, right? So the count here will be 4 as well, and these are the counts. Like first single A, second single A, and the third character that is B, and the fourth is palindromic subsequence. Well, nothing but the 2 A's together, right? So here for this case also, the answer will be 4. So if we have to consider for all the subsequences, right? So if you have to consider for all the possible cases, right? Because in this case, if you will see, so you have to consider for all possible subsequences, you can say, right? Or you can say that we have to consider for all possible cases. And whenever we have to consider for all possible cases, then the concept that comes to our mind is nothing but recursion. So the first thing is that we can solve this problem using recursion. And while we'll be solving it using recursion, so you can observe that we will be having a lot of overlapping subproblems. In that case, we can memorize it using the DP approach, right? So what will we do? Suppose if we pass initially, suppose in this case, if we start writing a little bit of code here, so what are the things that we will be requiring? So first thing is that we will need the length of the string. So let's say in if you remember, so in that case, if the plus one and j minus one, that says that I and j moves in, and then we keep on checking, right? But if they are not the same, then also we do something different. So suppose that if in this case, if they were the same, right? If they are the same, in that case, what we do? We will simply first of all, in this case, what we'll do? So if suppose that I is equal to j, so in that case, our approach will be different because if suppose that we are just standing at the last character, suppose we had a string x, y, p, q, r, w, something like this, okay? And suppose that our I was standing here and our j was also standing here, right? So if there is a single character that we have left in our subsequence, like if this is a single character only, that is this, and I and j are pointing both, so in that case, we'll simply return one because we'll be counting this kind of a subsequence, right? And other than this, what are the basic cases? So other basic cases can be that suppose if I becomes greater than j, right? Suppose if j is standing somewhere and I standing here, so if I and j cross each other, so this should not happen. So if I is greater than j, in that case, we'll simply return 0, indicating that okay, it's not possible. And other than this, if suppose that the dp of ij is not equal to -1, right? So if it's already calculated, in that case, we'll simply say that we will return that answer, right? So first of all, let's write these basic cases that we have just discussed now, right? So what we'll be having is first of all, we'll find the size of the string. So size of the string is nothing but str.size, right? Once we get the size of the string, so we'll have the dp declared for us because in this case we know that if we are considering for all possible cases, so there'll be a lot of overlapping subproblems which we can tackle using the dp approach, right? So we'll declare a dp which will be of size n, okay? And the second dimension will also be of size n, so we'll declare a vector of again a long. Let's say we will declare it as long, basically because the answer can be long range, right? So that's why we declare it as long. Okay, so after we have declared this particular vector, so we'll declare it as long here as well. So let's call here. So let's say we do what we return the recursion here, and we simply pass the string str that has been given to us. We pass the dp array as well. We pass initially 0, that is I will be pointing to the first character and j will be pointing to the last character of the string, right? And this particular recursive function will return the count of all possible subsequences that can be there, right? So how will we write this further? So first of all, let's consider the base cases and then we'll see for the other cases as well. So I'll write like long int recursion, and then first of all I'll be passing a string str, right? After passing the string str, we'll also require the 2d vector. So vector of vector, then the j plus say have something like a b c d, right? A b c d e, something like this if we have. So if our I standing here and our j is also standing here, so if I is equal to j, in that case there is a single character and that will always be palindromic in nature, so we'll simply return a 1 from it, right? That is what we are going to do. So we'll simply return a 1. Now what is the other base case? So if I is greater than j, right? If I and j cross each other, in that case we'll simply return 0, indicating that okay, the answer is not possible, right? Other than this, if we are using this, if we will have overlapping subproblems and we are using dp, so the dp of I is not equal to -1, this particular state is already calculated. In that case we'll return dp of I and j, right? That is what we'll do. Now comes the case when we'll consider all the other cases, right? So suppose if it happens, right? Suppose if there's a base, like if there's another case, like in this case, suppose that we have x, then we have y, then we have z, and then x, right? So if I is pointing to this point at this character and j is pointing to this character, so if str of I and str of j is the same, right? If they are the same, in that case what should I do? If they are the same, in that case I'll count 1 to my answer, right? I'll increment the answer by 1, and what I'll do is I'll try to call the recursive function. I'll pass the string, right? I'll pass the dp array and I'll call it for I plus 1 comma j. One time what I'll do is I'll like basically I'll call like if they are the same, right? So if they are the same, if they are the same, then my approach will be different. If they are not the same, then my approach will be different, right? So if they are the same, in that case what will I try to do? If they are the same, then one time I'll try to move my I and keep my j as the same. If they like other than this, what can I do is I can do another thing that I'll try to keep I as at the same point and I'll try to move j by 1, so j minus 1, right? So these are the cases, and I'll count this particular sequence that is this, they are the same, so I'll count this as a palindromic sequence by adding 1 to the answer, right? So if they are the same, that is what I'll try to do. So if the str to store the answer, because if I do, I'll simply write again the recursive function here. So one time like basically see then taking the modulus at every step that we have been told, because the answer can go out of range, out of the long range as well. So we'll take them out, right? So this is what we'll do. But if they are different, right? So if they are different, then we will have a different approach for solving it, right? So if suppose that we have a string that okay, what we'll be doing is if they are not like if they are not the same, right? So if they are not the same, then what can we try to do? So in that case we can say that okay, we can call recursively for I plus 1 comma j, right? One time plus the answer from I comma j plus 1, right? This is what we'll be getting. Like basically one time like if they are not the same, then after that if this is not the same, so then I'll keep I as the same, move my j here, then I'll try to check for x and y, right? And like basically I'll try to check for x and y, keeping I like first of all remains the same. So I could have one counting for here will be y, so y will be coming from it. So that means we are counting this y 2 times, whereas actually it is coming one time only, right? So in that case we need to subtract something as well. And what we'll subtract is we'll subtract simply y. Basically what we can say here is we can say that we'll subtract nothing but recursive of I plus 1 comma j minus 1 comma the string str, right? So basically in this case if we are passing this particular subsequence now, so the number of palindromic.
Oh, okay. This is interesting. Okay. Interesting, interesting.
subsequence from this string plus the number of palindromic subsequence from this string, that is nothing but I comma j plus 1, right? And this is nothing but I plus 1 comma j minus 1, right? Sorry, what I should have done is I comma j minus 1, right? Now this is one subsequence if it was x, y, z, right? So if I was pointing at x and j was pointing at, so one time I'll count it, one time I'll count the number of palindromic subsequence in this, and I'll count the number of palindromic subsequence from I plus 1, basically I plus 1 keeping the j as the same, right? And then I'll be subtracting what? Because I'm counting y 2 times. So basically I'll subtract nothing but I plus 1 comma j minus 1. Now, basically recursion of I plus 1 comma j minus 1. That is the number of palindromic subsequences that I'm getting from this particular substring, right? Because x, y, z, so if I move x and y both, so this is string. So basically this will be 1. And if I'm counting this y 2 times, now basically I'll be counting several occurrences multiple number of times. So if I want to count them exactly once, so I'll have to subtract this particular string from it. So that's what we'll be doing here. Now let's try and implement this thing here as well. So what I'll be doing here is
Why doesn't the same happen when I think we should subtract the same thing from here also? No? Uh, 1 plus
I'll simply say that I, right, basically one time I'll pass I plus 1, right? So after we are done with this first part, sort here as well, right? Because I need to keep this state for this particular current state I and j. So I'll simply return this particular key, right? So that's what I'll be doing here. Now let's try and compile this code to see if there's any error in this particular code. Okay, it was on the samples. Let's try and submit this code as well. So you can see that our solution was able to pass. Okay, so that's what I'll be doing here. Now let's try and compile this code to
why do we don't do this the same here? X, Y, X. Okay, so 1 plus XY and YX. So same thing should be done here. So, but it is not being done.
रिकर्शन में। ओके, ए बी मतलब जे घटाया हम लोग, ए बी में गया प्लस फिर आई को बढ़ाएंगे दूसरा टाइम में तो गया बी सी में रिकर्शन, और क्या बोला मैंने, एक बार माइनस कर दूंगा आई प्लस वन जे माइनस वन, मतलब बीच वाला मतलब बी माइनस हो जा रहा है हम लोग का। ठीक है, अब लोग देख सकते हैं जब हम लोग रिकर्शन में भेजे ना हम लोग, तो हम लोग का देखिए बी यहाँ पर आ रहा है, यहाँ भी बी आ रहा है, कर देंगे सिंपली वहाँ से 1 करेंगे। अब प्लस 1 क्यों करेंगे हम लोग, ये देख रहे हैं हम लोग ए और ए ये पहले तो बराबर मिल जा रहा है हम लोग, तो ये एक सब्स्टिट्यूशन हमको मिल गया तो वो एक आंसर में आ गया। और जो सेकंड रिकर्शन भेजेंगे ए बी और बी ए। अब आप सोच रहे होंगे कि हम लोग यहाँ भी तो बी 2 बार निकाल रहा है आंसर में, तो यहाँ माइनस क्यों नहीं किए, यहाँ भी तो कर सकते थे माइनस, पर क्यों यहाँ माइनस नहीं कर बता रहा हूँ मैं। देखिए अब यहाँ क्या देंगे, यहाँ बी से हमारे एक आंसर रिजल्ट होगा, रिटर्न होगा, इस बी से एक आंसर रिटर्न होगा, मतलब यहाँ 2 आंसर हम लोग को मिल रहा है, मतलब 2 आ रहा है रिटर्न हम लोग का यहाँ पर। ठीक है, तो हम लोग क्या किए, ये ए और ये ए उसका तो 1 ऐड कर ही दिए थे। ठीक है, और ये जो यहाँ से 2 आंसर रिटर्न हो रहा है जो बी वाला, तो ये अगर हम लोग यहाँ 16 बी लेते हैं तो उसके लिए एक ये वाला आंसर हुआ जो रिटर्न किया, और जो दूसरा आंसर रिटर्न किया उसमें लोग ये वाला पकड़ रहे हैं, ए बी ए पकड़ रहे हैं, उसका आंसर रिटर्न कर रहा है वो इस बी से। ठीक है, तो बेसिकली हम लोग का उस समय जब हम लोग का ए बी सी था यहाँ पर, तब क्या करते हैं हम लोग को सिर्फ बी 16 वाला एक आंसर चाहिए, बट ए बी सी तो नहीं ना हो सकता उसमें, कि हम लोग का पैरेंट्रोम नहीं है। बट हम लोग क्या किए यहाँ पर, हम लोग को पता है कि जब हम नहीं ना उसका तो 1 एक आंसर रिजल्ट होगा, रिटर्न होगा, इस बी से एक आंसर रिटर्न होगा, मतलब यहाँ 2 आंसर हम लोग को मिल रहा है, मतलब 2 आ रहा है रिटर्न हम लोग का यहाँ पर। ठीक है, तो हम लोग क्या किए, ये ए और ये ए उसका तो 1 ऐड कर ही दिए थे। ठीक है, और ये जो यहाँ से 2 आंसर रिटर्न हो रहा है जो बी वाला, तो ये अगर हम लोग यहाँ 16 बी लेते हैं तो उसके लिए एक ये वाला आंसर हुआ जो रिटर्न किया, और जो दूसरा आंसर रिटर्न किया उसमें लोग ये वाला पकड़ रहे हैं, ए बी ए पकड़ रहे हैं, उसका आंसर रिटर्न कर रहा है वो इस बी से। ठीक है, तो बेसिकली हम लोग का उस समय जब हम लोग का ए बी सी था यहाँ पर, तब क्या करते हैं हम लोग को सिर्फ बी
Oh, सही पकड़ा है।
सोलो वाला एक आंसर चाहिए, बट ए बी सी तो नहीं ना हो सकता उसमें, कि ये हम लोग का पैलिंड्रोम नहीं है। बट हम लोग क्या किए यहाँ पर, हम लोग को पता है कि जब हम लोग का ये और ये सेम है आई और जे, ठीक है, तो बीच वाला बी तो एक आंसर रिटर्न कर ही रहा है, और जो दूसरा आंसर रिटर्न कर रहा है वो बी इसको भी तो लेगा, एक वो भी तो एक सब्सिक्वेंस बनेगा, तो उसके लिए वो वाला आंसर वहाँ ऐड हो जाएगा। मतलब वो खुद का एक अकेला रहेगा जो एक बी से आंसर आ रहा है, और जो दूसरा बी से आंसर आ रहा है उसमें लोग पूरे को लेके चलेगा, मतलब जो उसका आगे पीछे में था, ठीक है। तो ये हुआ ये
सही है, सही है, सही है। ओके, कैन डू दिस। नो नीड दिस। इंट j I is equals to j, return 1. So if I greater than j, return 0. If s of I is equals to s of j, return solve of I plus 1 comma j plus solve of I comma j plus 1 plus 1. Good. S return minus plus 1. Good. I'll call this and minus 1. Cool. Now this is the rudimentary solution. We have to memorize it. S of j. There any errors that I can see of in my bare eyes? Implementation fault, sig fault. Cool. I is equals to the, if I is equals to j, return 1. If I greater than j, return 0. J minus 1. J minus 1. J minus 1. J minus 1. Cool. This is